So thank you very much, everyone. I am Gustavo Servec. I am from KPIT Technologies. I am leading the autonomous drive business in Europe. And in this keynote, I'm actually very happy to be here, I will be sharing with you one of our success histories at KPIT. And this is with one of our biggest customers. This is at Honda in Japan. And especially, I want to highlight also the contribution from IPG into this successful journey that we have with Honda. So, how everything started back then in 2016. So it was, this is a long time if you think, eight years ago. And we started with a bunch of challenges there at Honda. As always, you know, we have a chaos. There were a lot of things to do. We have black boxes models from the functions where you have no traceability to requirements. You don't have an architecture. You only have functionality there. And now was the challenge to industrialize everything, to make it serious of production, to make it really professional. And of course, part of that was to test it. And to test it, as you know, autonomous driving functions, they need a lot of data. They need a lot of training, machine learning, cascade detectors, or even now deep learning. You need the data. And you need a lot of kilometers, thousands of miles or kilometers, so you can have something really reasonable at the end. The coverage could be something reasonable at the end. And this was the big challenge. So what to do? At KPIT, then we started with reverse engineering these black boxes to make them white boxes. At the end, we succeed with that. But then it came the interesting part, what is the scale? How we're going to validate everything. So there were thousands of scenarios to be run, but first of all, they need to be created. And this is where IPG come into the picture. So we took a decision back then, 2016, to proceed with IPG as a partner for this journey, and it proved to be successful. I will tell you some details about that successful story, and I'm very happy to say that. But as you can see, well, we have grown a team with more than 80 people just working involved with IPG and more than 20 licenses. Of course, we have been using IPG tool landscape, the simulator, especially the simulator, the scenario creator. We have the mills, hills connectors also to the IPG, and we have the reprocessing and the digital twins, of course, with the excellence of the sensor models and the driving dynamics that are very accurate. This whole thing was possible. So as part of our pipeline, in KPIT, we have actually a homemade validation platform, validation framework. We are a service company, so we don't sell this as a product. This is not our business. Our business is to make our customers, to satisfy our customer with quality and excellence and good validation. So that's why we develop our own framework for accelerating and for making easier start the journey into the whole end-to-end validation aspect. So this platform already exists a couple of years, and strategically we made the decision now to embed completely IPG into this landscape. So you see in the picture, this is a complete framework which contains three main blocks. Is the data pipeline, where you have all this data ingesting information. You have the data curation, the data processing. Then you have the data-driven development part, where you have the labeling, you have the model training, the AI aspects of that. And in the last block, we have all this validation block, where we have, as you see, the three main areas where we have now IPG completely and fully integrated. And I will give you some insights of that. The critical scenario catalog is part of it, the reprocessing, and the K-SIL platform. The K-SIL is KPIT. X is for seal, mill, or hill, as it is more convenient. So it is a complete platform covering all these ways of testing. And this is already also part of our framework with, of course, IPG tool landscape. As you see the growth, I mean, I'm going to talk about the scenario catalog that we have now. This is very impressive. I mean, we started with 6,100 scenarios back then in 2016. And then if you see significantly the progress to 2024, coming from 6,000 scenarios to 3 million scenarios. So how is that possible in 8 years? Well, this is one of the reasons why we are working with IPG. It's not only to have a simulator and to create scenarios, but there should be something behind that enables us to stick with that solution and take the strategical decision to be with IPG CarMaker, with IPG and the CarMaker and tool landscape, sensor models, and everything that belongs to that. And especially one thing that I want to highlight is the support, because this support enables us also to keep integrating the tools and to expand the landscape. And even now we are working together with IPG in new offerings, in how to tackle the market, the new needs, the new challenges. And this is important to have a very good collaboration, very good support. Beyond, I think, is out of question the performance of the tooling, the sensor models, and especially the driving dynamics that is very accurate. So our catalog, as you see, 3 million scenarios. This is already there, up and running. It's part of a library. You see plenty of functions. L2++ till we now are starting with L3. This is what Honda is doing at this point. It's one of the few OEMs doing L3. I mean, you know Mercedes, BMW, but now Honda is also doing this L3. And we have this catalog that is proven, is running for, you see, diversity of driving functions from lane to traffic jam to assistance from highway assistance, parking, cruise control, with several hundred thousands of scenarios. This is the first big pillar that we have. This is the scenario database. The second part, where we have also very well integration, as I mentioned, is part of our pipeline of our framework, is integration with the mills, hills, and hills, where we have in the left side the IPG tool landscape, and we have the connectors to the mills, hills, and hills. This is very convenient because we mostly reuse everything either to the Fisher model for a mill testing, or we can use the same functionality over a Kanu framework also for connecting with our CIL environment, where I will explain a bit more of our CIL environment and a virtual ECU. And then that this is a very new thing we are still implementing, but it's already running. We have already some good demonstrators there. It's going also to the real ECUs with time constraints, real-time constraints solved with this HIL environment, and soon we will also get the HIL from IPG. I think it's in the next months we're going to start working also on that. And one thing that is also remarkable, and I talked to you about this simulation platform. This is one part of our framework, and I'm saying K-SIL, so I'm talking specifically for software in the loop simulation. And one remarkable thing is that this is also running on the cloud now. We enable that to be running on the cloud. That gives you some flexibility in case of parallel processing. If you have very tight time constraints, you need to test faster. Well, if you have on-premise, you are only constrained to what the resources you have at that point. But in the cloud, you have the flexibility to expand. But this also was possible because of the cooperation and the good support we have with IPG. We use mainly IPG as a simulator there with all these scenario creation parts. And it goes into the whole pipeline remotely from the data ingestion and then going to the results of the CIL platform. And the last thing that I want to say, because I don't want to extend too much, but I want you to see in reality what this platform, this big validation framework at KPIT looks like. And you will see also part of these integrations with IPG. And you will see you have a glimpse. Of course, this is just a high-level video. It's 3 minutes video. But then you will have an idea of what we're talking about when we're saying we know how to work at the scale, we know how to validate end-to-end, and of course, we are perfectly fine and very satisfied with the cooperation that we have with IPG, enabling us to create these scenarios, to use the simulator, and of course, to have a more completed framework delivering quality and performance out of that. So I will switch again to the video.
Presenting K-SIL, KPIT's in-house platform for end-to-end validation of ADAS and AD. From scenario automation to execution to KPI generation. Before we experience the platform, let's have a look at its architecture. The major components are the external APIs to access repositories and databases, both external as well as inbuilt, and most importantly, the modularly built test platform for scale. The K-SIL platform consists of a scenario library with over 3 million scenarios across features, platforms, and regulation. A framework for auto-generation of scenarios, a library of KPIs for various components that are built based on standards and regulations. A highly automated framework to create digital twins or extract scenarios from real-world drive data. Firstly, the critical environments are identified where a feature or function may have failed. Once the environments are identified, the next step is to do profiling. The stages of profiling vary based on the type and quality of data. Here's an example of how the lane and traffic profiling is done to identify the lane markings and the road structure. Additionally, various traffic participants and their relative motions with respect to the vehicle are also identified. Post-profiling, the digital twin is created, where the real road data is converted into synthetic data. This data can be run on any simulation engine. The primary purpose of creating a digital twin is to have a replica of the environment where a critical failure would have happened. As a result, the required software fixes can be tested on the virtual environment instead of recreating the same scenario on the real road. Most importantly, the K-SIL platform consists of a framework for both open-loop and closed-loop validation. The validation framework has APIs for integration of the AD stack and simulation engines with an easy-to-use user interface for test execution. Now, let's look at how to execute closed-loop validation in K-SIL. Step 1. Select scenarios from an existing or new library based on the AD stack. Once the scenarios are selected, the same are now available as a group for execution. Step 2. Push the scenario group into the scheduler, which is based on the needed computational power instances required parallel Docker to run integrated AD stack and simulation engine for validation of selected scenarios once the required mandatory system checks are completed. Step 3. View the status of the execution through the APM dashboard. Once the execution is complete, the data is moved to the analytics engine, where the auto-selected KPI based on the test strategy are evaluated. The results are displayed on a dashboard that shows multiple views, like a summary view or a detailed signal view. One can also download a complete report for analysis and replay. K-SIL offers multiple benefits like a ready scenario library. It is cloud-based and compatible with all cloud providers, and is simulator agnostic.
And actually, that's it. I just want to highlight something. As I said, our tooling is completely agnostic, but we have made the strategical decision to include IPG, and now we are in a very successful partnership and moving forward. I hope you have enjoyed the keynote and enjoyed the night. Thank you very much.